In this video, we'll begin our discussion of cosine. I'm going to show another video, but this is the setup again. Notice that I have a triangle. I'm going to move that side of that triangle to make a bunch of different triangles, but I'm going to keep the 19.9 degrees. So notice over here, I have the three sides that are measured. You can see where they're at. Okay, BC is here. Okay, AC is here. And then AB is here. Okay, notice what we're doing now. We are doing AC over AB. So that is this side right here next to our angle divided by our hypotenuse. So it's like, remember, sine was the y divided by the hypotenuse. Cosine now is going to be the x divided by the hypotenuse. Okay, so I'm going to show you this video. I got to move back over to it. So let's look at cosine. I have a video of cosine somewhere in here. There we go. Nope. Here we go. All right, so here's our video of cosine. Oh, that's my screenshot. Sorry, guys. Here we go. Here's cosine. So I move the sides, and you notice, okay, the sides are moving with my mouse. As I move it, I'm going to make the triangle extremely big, extremely small. And notice that when I take AC, the side next to the angle, and I divide it by the hypotenuse, I always get 0.9 here. It's going to stay the same, just like sine did. So the only thing really that our cosine is based on is the angle. Again, right? It's only the angle. As long as that angle is there and I draw a triangle and I divide my sides, that cosine, that ratio is going to stay the same. All right, so looking back here, we have cosine now is x, right? This side over r. That's how we define it. And it's just based on the people that came up with this noticed that, hey, as I move my triangle around and I keep that same angle, the ratio, the division stays the same. So cosine is x over r. Here's my picture again. And to just get this across, no matter where my y's were at, I had that all three of those were equal. It could be anything. So it makes the most sense now to draw a triangle and let that side there be a 1 to make our lives easy. If that's the case, then remember our cosine is just going to be based on that angle. And remember, it's just x over 1. So that means that if we have r equals 1, where our radius is 1 or that hypotenuse is 1, cosine is just x. That's great. Cosine is x. And then in the past video, sine was y. What's great too is these are in alphabetical order, right? Cosine x, sine y. It's very easy to memorize, right? So we got to get these in our head. Now, cosine isn't x always. It's only x when r equals 1. If r was not 1, like the triangles I have above, it's x over r, right? Not 1. The reason it's 1 is because we let it be 1, because when it's 1, we get this pretty relationship down here. All right, so let's look at our special angles that we've discussed in the previous videos and find the cosine. Okay, 60 degrees is pi over 3. That tells me that this is the tall triangle. I draw my triangle, there's my tall one, and I'm going to put my sides in. This is 1, and then to be tall, this has to be radical 3 over 2, while that has to be a 1/2. And we know those are the values because it's a 30, 60, 90, right? This is a 30, and then we got our 90. This is the reason that we spent time on those triangles. Okay, cosine of pi over 3, it's right here. Well, if it is the tall triangle, then I know that this side right here is 1/2, and we know this side's 1, and this side's radical 3 over 2. So if cosine is just x, then in this case, cosine of pi over 3 is just 1/2. Now, we go to our next angle. This is 2 pi over 3. And if I go all the way over there, I still get the same exact triangle. That's the beauty of this. And we want the x. Well, the x is right here. But since the x value is to the left, it's got to be negative. So cosine of 2 pi over 3 is negative 1/2 because the x, because cosine is x, the x goes to the left. Okay, we have another angle out here. This is going to be 2 pi over 3. This is 3 pi over 3. So this angle is 4 pi over 3. And we can see that it's the exact same x as the one before. It's negative 1/2. And then we got one more here, 5 pi over 3. You could either go up by a third, or you can think this is 6 pi over 3, all the way around once. That's 2 pi. Going back is 5 pi over 3. And you can see that the x value for this one is 1/2. Pretty easy if you know your 30, 60, 90s. Without it, drawing this is insane. So, and I'm going to get to the problems where, like, what are you going to have to draw a circle like this every time? Are you going to have to do all this stuff to get to this one little answer? No, you'll be able to just sketch it pretty quick, and I'll get to that. But you have to get the triangle where the angles are. So again, like I mentioned in last videos, if I were to mention 2 pi over 3, I would need you to know 2 pi over 3 is in quadrant 2, and it's the tall triangle. Okay, moving on. Let's deal with these if it was a 30, 60, 90, but 30 degree base. 30 is pi over 6, and this tells me it is a short triangle. So my short triangle, if I draw it, tells me that the big side has to be on the bottom, and the short side has to be on top if I want it to be short. All right, so that means that this side right here of this 30, 60, 90 is rad 3 over 2. Again, I copied and pasted a lot of this, so these are wrong. Okay, so that is pi over 6, and then, so that's this side. Let's go ahead and write that answer in. It's the x. Remember, this is 1, so I don't have to divide by r, or if I do, it's just dividing by 1. The next angle here, well, I know that this is 6 pi over 6. So going backwards would be 5 pi over 6, and going forward would be 7 pi over 6. Okay, and then this side, the middle side here, or the x, is the same as the other radical 3 over 2, but since it goes to the left, it's negative. X's to the left are negative. So cosine of 5 pi over 6, that angle is going to produce a negative 3 over 2, radical 3 over 2. Then we get 7 pi over 6, that's that next one. And that's that same x, right? Goes to the left, and it's the same value. Okay, our last one here, in case you can't get to the 6's, this is 12 pi over 6 for 2. I go back, it's 11 pi over 6. So cosine of 11 pi over 6 is that same radical 3 over 2 that we started with at the top. It's positive because it goes to the right, and the x's to the right are positive. Okay, we have one more triangle to deal with cosine. These are pi over 4. Pi over 4 gives us a mid triangle. So the mid triangle, the reason we call it mid is because the two sides are the same, and right in the middle, and the right in the middle value would be radical 2 over 2. You could even memorize it, radical 2 over 2. 2 and 2 are the same because the sides are the same, right? You know, that could help. So this first angle here is pi over 4. And remember, cosine is x. So in this case, this is radical 2 over 2. This is going to be the same thing. All we have to do is pay attention to the positive or negative stuff. Okay, the next one is going to be 3 pi over 4. And 3 pi over 4 is going to be the same side, so it's still radical 2 over 2, but since it goes to the left, it's negative radical 2. Remember, we can get this because cosine is x. Sine was y, cosine is x. Okay, this next value, this is a 4 pi over 4, so that means this one is a 5 pi over 4. And it's the same side. It's still the x, it's still to the left, so it's a negative. And then our last one, if you need help getting to it, this is 8 pi over 4 all the way around. So this is 7 pi over 4. And then it's this x right here, which is our positive, rad 2 over 2. Again, just like sine, we saw 3 different values. That's it here. 3 different values given plus or minuses, right? So I guess 6 different values if you want to be specific. But all you got to do is memorize those 3 values, right? And get them in and know which triangle goes where and what sides go with each triangle, and you'll be just fine at what's coming up.